So low quality solar, as I mentioned in the previous video, it's not that the solar is like of lesser quality. It's just a kind of an industry term that's used to describe how we use the sun. And really, this is kind of the low tech way that we use the sun. And in some ways, it's similar to thinking about the water wheel, right? We've been using, the Greeks were using a water wheel. We've been using low quality solar for ever, right? Ever since, people were around. So a couple of examples of using the sun to do your work for you. Clothes dryer, right? So actually, this is kind of an interesting story. I've worked, in the past, I worked for about 10 summers in Sardinia in Italy. Essentially, nobody owns a clothes dryer. It's really hard to find one, which is strange, but heck, it's the Mediterranean. It's warm all year round, and a clothes dryer is one of the most energy-intense things in your house. So, sticking up a clothesline, right? You can see here, it's beautiful clothes out on the line, April fresh and all of that sort of stuff, right? Even if it's August. But that's a way that we can take the energy from the sun and have it do a chore for us, right? Again, do work for us. So pretty standard. Obviously, another application of low-quality solar is lights. So again, I'm standing in a room. It's got some big windows over here that you can't see. I keep talking about them for some reason. And there's light that's coming through that window, and it's lighting up this room, which means free illumination, right? So illumination is really important to productivity. You got to have lights. But we can actually take some spaces and we can add skylights, which increase the natural light that we get during the day, and so we don't have to have electricity lighting up, dingy dark corners during the day. Right? We can increase how much natural light we get in an environment. Obviously, everyone has the same bedtime if that's the situation, right? Once the sun goes down, illumination's off. But still, it can definitely cut down on energy use during the day. Right? You might not need to turn the lights on in a room if there's enough natural light that comes in. So it definitely can decrease the amount of energy that you might use otherwise. Cooking. So using solar to cook is actually an interesting kind of both old-timey and modern application of low-quality solar. So again, you can see here, these are some solar ovens. It's just a glass panel. It's just kind of like a greenhouse, but it's lined with aluminum foil. And if they're pointed in the right direction and the sun is intense enough that day, you can bake some bread, right, without using electricity. Now, again, when we get to solar cooking, one of the things that we get to see here is that I mentioned it's a little bit modern. Well, there are some designs of really great and really fairly efficient solar ovens, kind of modern designs, that can allow people to cook. And particularly in places like, rural India and parts of rural Africa, that they generally cook with charcoal. They make charcoal from wood, and then they use that charcoal to cook every day. That's really intensive, especially on your kind of biological environment, right? If you're out chopping down trees in the forest to make charcoal, eventually that forest is going to be gone if your demand for charcoal is high enough. So there are currently a lot of people, NGOs and things like that are investing in building these fairly cheap solar ovens and distributing them widely so people have an alternative when it comes to cooking, which is, pretty cool. So as you guys go through the lifestyle project, which is starting this week, hopefully you've at least kind of checked some of that stuff out and starting to think about it. One of the things that you're going to find out is that a large portion of the energy that we use on a daily basis actually is dedicated just to heating water. Hot water is a huge sink on our electrical grid. No pun intended. So heating water directly with solar power, again, it's not using electricity. Basically, you're taking a bucket of water and setting it out in the sun to get warm, right? It's like making sun tea or something like that. But obviously, we're better at it now. We have these instruments that are fairly efficient. And so you can see here, this actually is such a thing. This is a solar water heater. It's got a couple of panels that, at least kind of on the outside, do look a little bit like a photovoltaic system, but they're not. On the inside, first of all, it's boxed off with a piece of glass or some other material. And then the inside is all coated black, so it will absorb the maximum amount of heat. And then there's just a series of pipes, which are also colored black, and water is cycled through this kind of circuitous, convoluted pathway through these pipes, and it's brought in cold, and it comes out hot. And then also you can see here there's a water tank up on the top, which can store hot water, so you're not just using hot water as it's created. They have some designs, where the hot water tank is actually in your house and it pumps up to your roof. It's a pretty cool system. And so again, if we look at certain places on Earth where electrical costs are fairly high, the usage of solar hot water is ubiquitous, right? Actually, this is a photo I took a while ago. My wife and I were in Fethiye in Turkey, and you can see here almost every roof has a solar hot water heater on it, right? That's the standard way that they generate hot water there. Again, here, this is actually in Sardinia in Italy, and you can see the same thing. Solar hot water heater after solar hot water heater after solar hot water heater. They do, I've spent some time using some of these systems. It definitely is a case where 8 people don't get hot showers, right? You kind of have to be wise about how you use your hot water because it's produced, by the sun at a certain rate. You can see here's a diagram of one that might be used in a cooler environment. So you can actually have your solar panel up on the roof, and cycling through that is actually not water. Something that's easier to heat up. Propylene glycol is common, something that won't freeze, especially if you live in a place like Idaho. And that's then brought down into a water heater and run through a heat exchanger. Well, as the hot water is coming in from the roof, hot water being brought from one place to another, that's convection, right? So by convection, we brought the energy down into the house. And then as it passes through the walls of the heat exchanger, that's transfer of energy by conduction, right? The wall of that heat exchanger will conduct energy from the hot water inside to the water inside of the tank. And also, this is the kind of thing you can make at home, right? You can get some plywood and some 2x4s and some sprinkler pipe and some black spray paint, and you can make a hot water heater. I've watched some videos on YouTube, and on a hot day, a sunny day here in Idaho, you could pull water that's 170 degrees Fahrenheit out. You could really get water pretty hot and store that energy. But speaking of Idaho and speaking of hot days in Idaho, not every place has the same potential for solar. So when we think about the Earth and the Sun, so the solar rays that are coming into the Earth are coming from the Sun, which is far away, so we can really just model them parallel. And if we think about how much energy hits one square meter at the equator, that's hitting really directly, but 1 square meter at the poles does not hit directly, meaning there's much less energy that hits that 1 square meter there than at the equator, which actually causes a temperature gradient on Earth, so everything that's hot will flow to cold, and that's kind of fundamentally why the wind blows, which we'll examine in a little bit more depth later. But you can see here, this is a map of global solar potential, and obviously, right along the center, right kind of in the area around the equator, that's where we have the highest capacity for solar. If we look at just the United States, here we can see, obviously, the desert Southwest. If we look at our big kind of national, or at least like fairly large solar power installations, they're all down where it's bright red. We can actually take a step back and dial in. Here's Idaho. If you look closely on the side, you can see Idaho doesn't have, the maximum solar capacity, but we're pretty good. If you've driven between Boise and Mountain Home, you've seen some of these photovoltaic installations. So we have a fairly high capacity for solar, at least in southern Idaho, but nationally, Our highest capacity is the desert Southwest, kind of Palm Springs inland, right? So southern Arizona, southern Utah, southern Nevada, kind of inland southern California, parts of Texas, Florida, right? Really, really, really famously sunny places where we can recover that energy. All right, so that's gonna touch all of the bases we need to for low quality solar, and then we're gonna dive in next and talk about actually generating electricity with the sun, which we haven't done yet. All right, see you then.